All right, so 2015 4D. Okay, so on 4D, find the values of the constants m and b for which y equals mx plus b is a solution of the differential equation. So there's usually like one part that might look a little different for most tests, but if you just know the free response questions really well, you should not get enough. You should know enough to pass with a 5, honestly, at least a 4, but probably a 5. So for this one here, 4D might be a little different. So there's going to be some parts that are different. Don't let that bring you down. If you don't know what to do. Yeah, question?
So is your final going to be not like how you said earlier, how all the tests are in the same format, like it's the same problem? Are your tests going to be like, is your final going to be like that?
Yeah, the final is going to be in the same format as all the FRQs you've been doing. It's just the first problem will have a couple more parts because it's 25 minutes. That's what I anticipate your AP test is going to look like.
All right, thank you.
All right, so 4D, I'm going to start off, dy over dx is another way to say your slope. So that's going to be m. So we know that m equals, what do we have here? So our slope is 2x minus y. That's our dy over dx. So if I'm solving for m, I'm going to say m equals 2x minus, instead of y, we know that, what do we have here? So y, I can use the fact that y equals mx plus b. Little scratch work up here. So I'm going to say instead of y here, I'm going to change that to mx plus b. So now I have one less variable I have to worry about, even though now I have a b. But we're doing it in terms of m and b. So somehow you have to write this equation in terms of m and b, because that's what it's asking you to solve for, those two values. Okay, so right here, I am going to subtract m to both sides to get 0. So I have 2x, I'm going to distribute the negative. And then I'm subtracting m to the left side, and then I'm also subtracting m on the right side. So here's the minus m. So I'm trying to solve this equation for m and b. So I can, for these first two terms, I can factor out an x. So when I factor out an x, I'm left with 2 minus m. And then I'm going to factor out a negative 1 here. And that's going to leave me with m plus b if you switch the order. Okay, so here we want this. If you think of this as like y equals mx plus b, the 2 minus m would be like your slope here. So 2 minus m. In order for this equation to be 0, the only way that's possible is if 2 minus m equals 0. Because that'll wipe out the first term, because 0 times anything, 0 times x is going to give you 0. And then the constant would also have to be 0. So if both of these parentheses equal 0, it's going to make the entire right side of the equation 0. So both of these must be true. So I'm going to say and. Both equations need to equal 0. Okay, so for this first equation, I'm going to get m equals 2. So that's going to be my first answer. And then now that I know that m must equal 2, I can plug that into the second equation and then solve for b. So this is one that most students, I'll just be honest, are going to miss. And then the writers of the test know that there's certain problems that very few students are going to get right. They just include those for whatever reason. So this would be one of them. And this is one I mentioned earlier. It doesn't look like a lot of the other problems you're used to seeing.
Yeah, so that's going to be one that's like rarely going to come up, right? Like it's going to be on each test.
Yeah, there's always going to be some curveballs. You just have to know they're going to be coming. You don't want the problems you don't know how to do affect your performance on the problems you do know how to do. There's just going to be problems that are going to be complicated problems you haven't seen before. That's to be expected. you only need to get 60% of the points right, approximately, to get a 5 on the AP test. So it's designed in a way where you're not supposed to get 100%. So don't beat yourself up. Just focus on the treasures, the problems you know how to do. And that's why I mentioned before, it's important that you it's okay to spend more time on the easy ones and make sure you get those right, get all the points for the easy ones. And you can even, if you recognize, part of the battle is recognizing what are the easy problems and what are the hard ones. As you practice, you do more of the FRQs, you're going to start to see, just from a quick glance at the problem, you'll know if it's one of the easy ones or the hard ones. So if it's a hard one, I'd save those for last. If you don't get to them, that's okay. You can still get a 5 without having to do any of the hard problems. And by hard, I mean problems that aren't the predictable problems, ones that are like 4D. But if you can get 4D, that's great. Those are extra points for you. All right, so any other questions on number 4?
Can you do 4C?
4C, yep. So I'm going to clear off 4D, and I'm going to switch to 4C. Okay, so 4C now. So here it's asking about if it has a relative max or a min. So right away you should think I have to find the derivative and set the derivative equal to 0. So the derivative, I'm going to write that as dy over dx. At this point, that means you're working with an x and a y coordinate. So this is the point 2, 3. And we're given an equation up here for dy over dx. So I'm going to set this, so 2x minus y. We know that x is 2, we know y is 3. And I'm going to see what this equals. So at 2, 3, you can see the derivative, 4 minus 3 is 1. Well, to be a relative min or a relative max, doesn't the derivative have to equal 0? So the tangent line is not, the slope of the tangent line is not 0. It's not a horizontal tangent line. So if it's not a horizontal tangent line, the answer would be no. So make sure you justify your answer. You could say no, and the reason is dy over dx at 2, 3 does not equal 0. So how you write your answer is important. It'd be, you might know why, but if you can't explain it correctly, you're not going to get the justification point. So use clear language when you're writing. And we'll talk about that a little bit more today and next week, what it means to use clear language. But it's very important that you write it correct, mathematically in a correct way, because if you don't, you're not going to get the point that should be an easy point after you already figured out that it's not a relative max or min. Make sure you can correctly justify.
Wait, so the answer would be neither?
Yeah, I would say neither instead of no. I think that they would still give you the point if you said no, if you justified it correctly, but just to be safe. So neither would be the correct answer. It doesn't have a minimum or a maximum because the derivative never equals 0.
Mr. Morrison, for 4C,
Yes.
if it was 0, then you would have to test points to find out whether it was a min or a max, right?
Correct. So you'd have to you could do the second derivative test or the first derivative test in order to show if it's a max or a min. So I like the questions. Again, my goal is not to finish every FRQ problem through 2008. So I want to make sure to get your questions answered and talk about like how it's going to be graded as we go. Was there a question a second ago? Okay, might have been background noise. I had already a question. Okay, anything else on number 4?
What if you said there was like, I said no, but because the 2 has a slope. Is that too like general?
What do you mean 2 has it?
Like my explanation was neither, because 2, 3 has a positive slope at x equals 2.
As long as you can show that it has a positive slope, that should be fine.
Yeah, because the slope is 1. So
Yeah, if you can show that it has a positive slope, yeah, that should be fine. I would actually, I'd probably state it does not equal 0 because that's how you know it's not a max. because it could be positive or negative. As long as it's not 0, that would make it neither. Okay, so good questions. Anything else here on this one? All right, going to number 5. I think we skipped, I checked it, I believe it was 6C was skipped. So I should be better prepared this time. I know I'm often having to ask you which ones were skipped. Okay, so number 5, you see another K problem. You seem to show up often. So you have to work with some unknown constant, unknown coefficient in front of the X. Okay, so questions on number 5 from 2015.
Can you do 5C?
5C, yep. So let's see at 5C. Find the value of K for which F has a critical point. So you see critical point, you have to think, what is a critical point? So that's an X, or that's a point on your graph where the derivative is either 0 or undefined. Okay, so for 5C, I'll do it down here. So on 5C, I'm going to find, we know the derivative. So we're given the formula at the top, so it's f prime of, and we're told that x equals -5. So that means everywhere I see a -5, I'm going to put, everywhere I see an x, I'm going to substitute with a -5. So it's going to be k minus 2 times -5 over, on the bottom, I have -5 squared. I'm going to do a parenthesis at the front, minus k times -5. And this is getting squared, and this needs to either be 0 or undefined. Well, if you notice, the denominator will never be 0. No matter what k is, if you're squaring it, and then you're adding, you're doing 25 minus something. Let's see, could k, I'm thinking, how could inside the parentheses be 0? If k was -5. Okay, well, let's see what happens. I'll start with the numerator. So I'm going to say that f prime of -5 equals 0 when the numerator is 0. So when k minus 2 times -5 equals 0. So here, this would give me, when I solve this, this is going to give me k equals -10. Okay, in order, let's see, this is 5C, to be a critical point. So k equals -10 would work. To be a critical point. So that should be, I'm just focusing on the numerator here. And let me see, can the denominator, 25. For what find the value, okay. Well, if it says value, that's singular. It would say find the values if there's more than one. So I think if it said critical value, you might have to set the denominator equal to 0, but for this one, it's actually talking about a critical point. So in order to be a max or a min, the derivative has to exist at those points. So just be k equals -10. So is that okay for 5C?
Yeah.
Okay. So again, a lot of it is just knowing what to do first, knowing what the definition of a critical point is, and then the math itself should not be that difficult. And especially if it's a 45-minute test, I know for like 99% certain they're not going to give you long algebraic problems. They're just going to try to quickly test what you know.
Can you explain that last part you said again?
So the derivative equals 0 when the numerator is 0. So I set the numerator equal to 0 and I solved for k. To make it, because a critical point has to have an x and a y coordinate on the graph. So where the derivative is undefined, let me actually see what happens here. I'm trying to, so if I set -5, don't write this down. So if this equals 0, that would be 25 plus 5k equals 0. So yeah, it would be -5. I feel like I need to refresh myself again. I haven't done this in a while. K is a non-zero constant. I know if it says find the value, that means there's only one. So I know for sure the numerator is going to be good. But I think if, let me see, if I have the yellow book, I want to reread the definition of a critical point. Should be here. Or actually, you know what? I'll come back to this when we're doing the extra credit later. Unless I can find it really quickly. Yeah, critical values, I'm reading, it says where the derivative is 0 or undefined. But I think because it says critical point, it has to be an actual point. So that's the key word. So critical point means only consider where the derivative is 0. But that's a little tricky because I might have even thought, if I wasn't looking at the word find the value, I might have thought 2 answers. But when it says find the value, that tells me there's only one value. All right, so anything else on number 5? So this part is not necessary here. That if it said find the critical value, then I think you would have to consider where it's undefined also. Sometimes they can get really specific with the definition. So questions on number 5 before we go to number 6. Okay, gonna clear this out. So last problem on 2015. Again, I'm probably more convinced than anything else you're gonna see series on there. I don't think it can be a VC test if it doesn't include series. I said series and my phone thought I said Siri. So questions on number 6.
Letter A.
Letter A, let's look at letter A. So you do need to know ratio test. You don't have to know everything we did on series, but you need to know close to half of what we did. And then again, I mentioned this on the Google post, all the topics that you can skip. Again, hopefully you guys are able to watch those videos. I had a chance to watch a couple of them and they are very good. So I know some of your other AP teachers might be requiring them. I'm already giving a lot, so I don't want to require them, but I definitely would encourage you to go through those videos. I sent you some virtual handouts yesterday on the Dropbox link, and it had so each one came in pairs. So it had like the handout to be filled out and then the other handout with the worked out solution. So at the very minimum, I would look through the worked out solutions. It doesn't take that long. Hopefully you have a chance to watch through the videos though and see these are people that are involved in like the process of writing the tests that are teaching these classes. So that's going to be a huge benefit to go through those. Okay, so 6A, use ratio test to find R. So ratio test, this means I'm going to take the limit as n approaches infinity. These are little things you want to remember. It's always the limit as n approaches infinity. I'm going to do absolute value. It's going to be, I'm going to take this general term, and then everywhere I see an n, I'm going to add 1. So when you have n minus 1, when you change that n to an n plus 1, n plus 1 minus 1 is just n. And then I have x to the n plus 1 over, instead of n, I just put in the numerator, no big deal. So x to the n plus 1, and then over n plus 1. And then I'm going to divide by the general term. That's the same as timesing by the reciprocal. So the reciprocal would have n in the numerator. Then it'll have -3. I should put -3 in parentheses here. -3 to the n minus 1. And then x to the n is originally in the numerator. So when you take the reciprocal, it's going to go to the denominator. And in order for user to find r, so even though they're not going to specifically test you on radius of convergence, this is still good practice because they can test you on ratio test. So doing the ratio test, you need to know that if it converges, this limit needs to be smaller than 1. If it equals 1, it's inconclusive. Greater than 1, it diverges. Okay, so to simplify this, so that's why I included this problem, even though you don't have to know radius convergence. It's good practice because ratio tests can and probably will be on there. Okay, so -3, because we're going to infinity, these two can cancel out. When you subtract the exponents here, n plus 1 minus n is just x. So that's going to give me an x here. And then when you take the common bases, you subtract the exponents here. I'm going to do a little scratch work. So I'm subtracting the exponents, n minus 1 in parentheses. So this will become n minus n plus 1, which just equals 1. So 3 to the 1 is just 3. And I'm going to do absolute value of this. So to say the absolute value of 3x is less than 1, that's the same as saying 3x is between -1 and 1. So just solve this equation for x. And this is centered at 0, because this is x minus 0 in disguise. So 0 would be the center. So it has a distance of 1/3 to either endpoint. So the radius of convergence, I'll call it r, would equal 1/3. And again, you don't have to stress over the radius of convergence part. So if you see something that asks for radius of convergence, it doesn't mean skip the problem, but just make sure you know how to do it. I'd still probably practice it because it's good practice of doing ratio test. So anything else on number 6?
Can we look at 6B?
6B, yep. So let's look at 6B now. Okay, so on 6B, I'm given the function at the top, and then I'm going to find, it's asking about f prime. So I'm going to say f prime of x. It says we're only doing the first 4 terms, so I'm going to say approximately. So when I take the derivative of x, the first term, it's going to give me 1. When I take the derivative of the second term, it's going to give me minus 3x. When I take the derivative of the third term, it's going to be 9x squared. And if you follow this pattern, you just keep multiplying the previous term by -3x. So when you do 9x squared times -3x, it's going to give you -27x cubed. This one's geometric. So that would be the first 4 terms, and then express as a rational function. So rational function, first 4 or 5 letters of rational spell ratio. So whenever it's geometric, I gave you a formula for a geometric series. It's going to be the starting term over 1 minus r. So that creates a ratio, a rational function, a over 1 minus r. So a, I'm going to say equals here, because this is going to represent the entire geometric function. So it's going to be the starting term. So a is just 1, the starting term. And then r is the thing that we keep multiplying by. So 1 minus r So r is going to be negative 3x, because going from left to right, we just keep multiplying by negative 3x. If you're not sure, just take the second term and divide by the first term. So negative 3x divided by 1 gives you negative 3x. Or you could take any term and divide by its term on the left. It always gives you negative 3x. If you left your answer like this would be fine. If you want to simplify, that's fine too. And geometric is one of the problems that can show up. So you are expected to know geometric series. So make sure you go back over that Google post. Hopefully you've gone over it a few times and you know by now. But if you ever need a reference, it is in your Google Classroom announcements. You can see all the concepts that you need to know, and all the ones, or actually not all the ones you need to know, but all the ones that can be skipped. And geometric, I specified also for series what you do need to know. So geometric is one of the ones you do need to know. So that's all we had for 6. So any other questions before we go to 2014?
How'd you find R again?
R is just the common ratio. It's what you're multiplying by from left to right. So if you know it's geometric, in order to get a rational function, it has to be geometric. That would be a clue right there. If it asks for a rational function, that tells you that it's geometric. So it's saying, what are you multiplying by from left to right? If you're not sure, just take the second term and divide by the first term. That will always give you R. That's a cool problem. Sometimes I'm just amazed at the people that think up these problems. Probably takes a lot of time. Okay, so we're okay, 2015? Okay, I'm gonna go to 2014 now. It's nice. Originally, I think I had this plan, like I was gonna get through 2018. I'm just okay with that not happening now. I think we're gonna get more out of it by just making sure that we don't rush through these. We're gonna do the best we can. So we're not gonna be doing any calculus review on Friday. Friday is gonna just focus on the final. And I think I explained it, but I'm assuming I'm gonna get your AP test back before the grades are due. But I'm always afraid that might not happen. And they said we're supposed to get it back in May, but they haven't specified which day yet. So I want to make sure you at least have a final, but hopefully this Friday will average with the one that you're taking on Friday. So hopefully you guys are okay being flexible there, but I'm hoping that, yeah, I'll be able to get that back in time. But I think there's a couple people that aren't taking it too, so that's also important. I think that we do a final before the AP exam. Okay, so right here we have 2014. So I'm guessing it's a rate in, rate out problem. I haven't even looked at it. Maybe it's not. Is it rate in, rate out? Oh, maybe it's not. Anyways, any questions on number 1?
One D.
1D. Okay, before I do 1D, I'm looking at 1B. That just seems like a really good problem to ask. Explain what the meaning of something is. Because they're probably going to try to give you some problems where it makes it hard for people to cheat. B would be one of those where if you have like the exact same answer like to the letter that someone else has, it might look pretty suspicious. So explaining, I could definitely see more explain and justify type problems this year. Okay, so 1D, find the, you said 1D, correct?
Yes.
Okay, so 1D, it's a linear approximation. So you could do point slope form. So for 1D, do y minus, this creates a linearization where y is the same as L of x. I'm just gonna use y instead, it's just easier to work with. So y minus y1 equals m times x minus x1. I like when there's not a lag. This is nice. Okay, so here, I guess they're calling it L of t here, so maybe I'll use L of t. So I'm basing it off of point slope form. So L of t is my y. If we're doing it at t equals 30, that's gonna be, we're gonna find, it says approximation for a. So I'm gonna call this a of 30. That's gonna give me a y coordinate. So think of t as your x value and a of t is your y value. So in this case, your t is 30. And then it's gonna equal m, which is the slope. So that's a prime at the point where t equals 30, times x, which is, I'm gonna use t instead of x. So my x, just to make sure it's clear, x1, y1, that's the same as 30, and then a of 30. So that's gonna be my test point. And I'm finding the slope at that point, so that's gonna be a prime of 30. So this is another good problem that forces you to, yeah, I really think they're gonna give problems kind of similar to this one where you have to make some connections to other things you've learned. Okay, so L of t is just gonna stay as L of t. That's what makes it a function. T is gonna stay as t. That's your independent variable. L of t is your dependent variable. So at this point, we're trying to figure out what t equals. So L of t, you know what, let me backtrack. Because we know L of t is, we want to figure out what point there will be 0.5 pounds of grass. So that's going to be my L of t. A of 30, you just plug 30 into this function up here for a. So when you plug 30 into that, I'll just leave it as 6.687 times 0.931 to the 30. Equals, then we need to find the slope. So you would do this on your calculator. This one wouldn't be on your AP test because it doesn't require a calculator. I mean, there might be a problem like this, but this specific part would not be on there. It would probably give you the slope if it was to do this same type of problem. So you would, on your calculator, you guys remember math 8? So you'd calculate the slope of this, the derivative of this at 30. And then that's going to be, so using your calculator, it's gonna be 559.76213, and then t minus 30. And then from here, you would write your, you could leave your answer, normally you could leave your answer like this. It'll be everything on the right side. 687 or 6 times 0.931 to the 30. And then we're gonna divide this by, normally you would do all this on your calculator, but I'm just gonna kind of set up how you get the answer. 6213, and at the very end you would have to add 30 to both sides. So on your AP test, you could leave your answer like this. And it doesn't say to include units anywhere. But for time, oh, I guess it would be in days. I would just include units to be safe, but sometimes it specifically says include units, and then you need to say units or you lose the point. All right, so other questions on number 1.
So whenever it says linear approximation, you do the y minus y1 equals m
Correct. And then remember, y is the same as L of x. So in first semester, when we talked about linearizations, L of x was just the same as your y coordinate. So it just, yeah, that just represented the approximation. So what you're doing with the linearization, so you have a point here. I'm just going to make up a graph. So you might have a point here. Let's say this is 30. So you'd have a tangent line. So this would be your tangent line. And so let's say near 30, you could find the approximation, because see how any point close to the point of tangency is pretty close to the graph. So if you find the y coordinate close to 30, you're approximating the y coordinate on the actual graph using a tangent line. So that's what linearizations are used for, to give you an approximation near a point. Excuse me.
That was funny.
No, it wasn't, Jacob. You can keep your mic off. Okay, any other questions on number 1? All right, next one is number 2. Number 2 is skipped. That's polar. So nice not having to do the polar ones. Those are usually the hardest, some of the hardest problems are the polars. So originally I wasn't happy that they took some of that stuff off, but now looking back, it allows us more time to focus on the other problems. So that's a good thing. Okay, so questions on number 3. You see how number 3 always looks like this? It's just, again, this year it's a little different because there's 2 problems, but there's certain problems that just show up every year. It's crazy. A function defined as an integral, and it's always number 3. I don't feel like they're trying to surprise you. Maybe they don't know how. Maybe they don't have the creativity to surprise you. There's always a couple surprises, but most of the time it's pretty similar. And the guy who's the vice president of College Board said they should be traditional free response questions. So that tells me it looks pretty similar to the ones they've had over the last several years. I hope I'm not lying. Well, it's not me lying. I'm just the messenger. So hopefully that'll be a good thing if it's close to old ones, because that's what we're going over now. So last call, any questions on number 3?
Can we do 3C?
3C, yep. So 3C. Oops, backtrack here. Just trying to give myself a little more room. Okay, so 3C. So for this one, if I want to find h prime of 3, I have to first take this function here and find the derivative. So you're going to have to do quotient rule whenever you have a variable on top and bottom. So doing quotient rule, this is what we live for. Ho-dee hi minus hi-dee ho over ho-ho. So ho, d hi minus hi, d ho. So that's just going to be 5. Everything over ho-ho. Okay, it's a prime of 3. So everywhere I see an x, I'm going to substitute a 3. So it's 5 times 3 times g prime of 3 minus g of 3 times 5 over 5 times 3, that whole thing squared. So you have a function defined as an integral. Notice they're giving you the graph of f, and they're defining the function as g. So I want to figure out how I can relate the functions g and x. So I'm gonna do fundamental theorem of calculus like you always do on number 3. So I'm gonna take the derivative of both sides. It should be getting easier every single test because the first test is probably very difficult because it's a lot, maybe it's a lot more new material, but now it should be getting more familiar. So when I take the derivative of the right side, it's just gonna be f of x. The -3 means nothing to me because it's a constant. So you take the derivative of a constant, later it becomes 0. So I just took the derivative of the left side and the right side. So now I can say that this graph f is the same as the derivative of g. Okay, so if I want to find g prime of 3, that's the same as f of 3. Well, f of 3 is just the y coordinate on the graph. So at 3, where's 3? Right here. So this point right here, that has a y coordinate of -2. If you're not sure, you can use the slope of the segment. So it looks like we're going down 4/2, so down 2/1, down 2/1, down 2/1. That would give you a y coordinate of -2. And then if you want to find, so that gives me this value here is going to be -2. And then to get g of 3, g of 3 is going to equal the integral from -3 to x. So now I'm just plugging in for x, I'm plugging in 3. So that means using the graph of f, I'm going to find the area from -3 to 3. So from -3 to 3, that's going to be this area here. So 2 triangles. So this top triangle has an area, let's see, the base is 1, 2, 3, 4, 5, 5 by 4. So half of 4 times, or half of 5 times 4, half of 20 is 10. Let me just double check that. Okay, that should be good. And then right here, this is over 1 down 2. So this triangle right here has an area of -1. 1/2 times 1 times 2. So it's going to be 1, and it's negative because it's below the x-axis. So when you add 10 and -1, that's going to give you an area of 9. So now I can substitute back in. So 5 times, you can actually leave your answer like this. Why simplify if you don't have to? Times g prime of 3 is -2, we found in red, minus 9 times 5 over 5 times 3 squared. Please don't simplify this. It'd be so sad to do all this work correctly and then lose the point because you simplified it incorrectly. So just leave your answer like I have it there. Anything you can do on a scientific calculator, you don't have to do on the AP test. You can just leave it in unsimplified form. Just make sure you do all the calculus. Take all the derivatives, take all the integrals, but if it's just arithmetic, you don't need to simplify. You don't have to reduce, anything like that. Let me circle this in green since I didn't circle it. So this is what I was plugging in for green. Anything else on number 3? Okay, going to number 4. Let's see, number 4, let me clear this out. So you guys are doing okay. Like I said, it's never the same as in class. I'm still really sad about the talons. It doesn't compare to your guys' sadness. You have a lot more you're missing out on than I am, and I understand that. But I look forward to the talents. It's like a party. I'm just busting music really loud, all this fun group work, all these Kahoot activities, but that's okay. All right, so question number 4 on 2014.
C.
You said C is in cat?
Yes.
Okay. C like Spanish, yes. Okay, so question 4. Letter C. Okay, so we have a train here. So an integral, okay. So this looks like one of those problems that show up so frequently where I'm going to do final value or final position. So I'm doing 4C here. So final position equals starting position plus net change. Okay, so the final position, I'm going to use S for position, and it's position of train A. So I'm going to use S to represent position, or S of T. And I'll say S sub A, position of train A, in case there's another part that requires position of train B. So the final position it's going to be at T equals 2. Oh, no, the final position will be at T equals 12. So we're starting at 2, we're finishing at 12. So the final position is going to be the starting position. Plus the net change, which always involves using an integral. So it's going to be the integral we started at 2, we're finishing at 12. This is going to be our net change. And then to get the change, you integrate the velocity. So you undo velocity to get back to the change in position. So it's going to look like this. So V, sorry. So the velocity of train A at T. So the hardest part is usually the setup. Again, first step, I always try to emphasize, and that's what the yellow book is so helpful for. So maybe after this one, I'll talk about a couple things in the yellow book. But this is your setup. So the final position of the train equals the starting position plus the change, net change. Okay, so right here is what we're trying to solve for. We want to find the position after 12 minutes have passed. So it's going to equal the starting position. So it says we're starting out 300 meters east of the origin state. Oh, I see what they're doing. Origin, that's a mathematical word. Okay, so east of the origin. So 300 is the starting position. Plus, and it says to use trapezoidal sum. So it's not actually giving you a function here. It's giving you a table. So to find the net change, I should change this to approximating because we're approximating. So we're not finding the actual final position. We're approximating the final position. So to figure out what this is here, I am going to use the trapezoidal sum. So to do that, you can factor out a 1/2. So you don't have to keep dividing by 2 to average the bases. Let's see here. We're going from 2 to 12. So from 2 to 5, 5 to 8, and 8 to 12. So we're going, here we're adding 3, Here we're adding 3, here we're adding 4. So that represents the height. The length of the interval along the x-axis is the height of your trapezoid. So it's going to look like this. So it's going to be 3 times, and then 100 plus 40. That we're averaging the bases. You don't have to divide by 2 because we already factored out the 1/2. So 100 plus 40. Plus, for the next trapezoid, from 5 to 8, it has the height of 3. And then we're going to average those bases. So we already factored out the 1/2. So I'm just going to add 40 and negative 120. You don't have to factor out the 1/2. You could just find the average of all the bases and just divide them all by 2. That's fine. And then going from 8 to 12, that gives me a height of the trapezoid of 4. And we're going to average negative 120 and negative 150. Those are the bases. And this is a great problem to just leave your answer like this. Say, I'm going to say meters. But if you want to check your answer, which I'm sure you do, make sure to plug that into your calculator, and it will give you, it should give you the answer that it says on your solution page. Are you guys seeing the beauty in calculus through working through FRQs?
Yes.
That's what I like to hear. Thank you for the feedback. Okay, so other questions on number 4. So really pay attention to this first step. Okay, so on the first step, I'm taking the final position, starting position, but then I'm integrating the velocity to find the net change, because that's going to give me my change in position. So that's a very, very important concept to understand. So in this case, it would be net change in position. Sometimes I use the word value. Here I use the word position.
Can you do D, please?
Yep, let's look at D. So I'm going to clear this off if there are no objections. Okay, so clearing off number 4. 4 looks like a rate of change problem. No, or related rates, I mean. Okay, so on 4D, we have 2 trains. Now we're working with train B. So I'm going to draw a right triangle because we're going north-south and then east-west. So I'll just say train A is here, train B is here. And then we're working at t equals 2. So we know from part C that at t equals 2, train A is 300 meters east. So I'm going to say 300 meters. And then here it tells you at t equals 2, it's 400 meters north. So this would be 400 meters. And I can do Pythagorean theorem now. This is based off of a 3, 4, 5 right triangle. If you want to do Pythagorean theorem, you can, but that's going to give you 500 meters. Is this distance here? And I'll just call this side C, even though there's no train C. Just if we need to reference it later. Okay, so I'm going to write an equation that relates all these sides. So that would be Pythagorean theorem. So we know that a squared plus b squared equals c squared. And because it's a related rate problem, I'm going to take the derivative of both sides. So I take the derivative of the left side. I'm doing it with respect to t, to time. So that means I'm doing implicit differentiation. That's the same as doing chain rule. So 2a times the derivative of a with respect to t. So dA over dt take the derivative of b with respect to time times db over dt. And then the derivative of c squared with respect to time. Okay, the table is going to be helpful here. So A, we know A is 300 from our picture. And then dA over dt, that's the derivative. So that's the same as the velocity here. So at 2, the derivative is going to be 100. So that's what I'm going to plug in for my dA over dt. I'm taking the derivative of the position, which is the same as the velocity. So at 2 minutes, it's going to be 100 meters per minute. Okay, so then I have 2. We know B is 400. And then to find dB over dt, dB over dt, is that given anywhere?
I think we have to find it, Mr. Morse.
Oh, we have to find it. Okay, so we're given the velocity. So that means you would just plug in 2 here. So it's, I'm going to do -5 times, because t is 2, so 2 squared plus 60 times 2 plus 25. This is going to equal 2 times c. We know c is 500. And then dc over dt. This would be where if train A is going this way, train B is going this way. C represents how far they are away from each other. Because A is going east, train A is going east, train B is going north. So that means dc over dt, it says find the rate in per minute, the distance between A and B. So that means we are solving for dc over dt. That describes the rate of change, or how the distance between train A and train B is changing. So this is our unknown, this is our variable. So I'm going to leave this as dc over dt. And then how you should write your answer here, you would just say dc over dt equals, so I have 2, if it's faster to just do it in your head, that's fine, but I would definitely advise against simplifying for most problems. So I'm just going to leave it like this. Even something simple, if you make a careless mistake, I don't want you to lose the answer point. But sometimes it might be faster to just simplify a couple parts in your head, and that's fine. Here, I'm just going to write it all out. Why do I have a t here? Oh, this t should be 2. This one might take longer to write than to simplify part of it. Just plug in your calculator. So over 2 times 500. And this one is in meters per minute. That took a long time to write. And while I'm thinking about it, even though there's no sub-score, I do know they're going to have AB questions on there. And the fact that you have to do AB stuff to do BC stuff. I think someone asked me a couple weeks ago, I think it was Melissa, about taking the BC or the AB. The BC test is not supposed to be harder. It's just more concepts. So if we've already learned the material, it makes sense to just go for 2 years of calculus instead of 1. So, and then hopefully you're not one of the 10% of students that there are some students that score better on the AB, but I'd say a good 90% or so score the same on the BC and the AB sub-score. That's why I didn't think it was that big a deal. It would be nice to have the AB sub-score, but most likely you're going to get the same score on both. And if you get a 5 on the BC score, your AB subscore doesn't matter. You get 2 years of calculus at most schools.
Just a sec. Who do you want to?
Okay, so other questions on number 4? Okay, we're gonna go to number 5. Just kidding, number 6. Wait, no, 5, we need to do 5. I thought it was a polar question at first. Okay, so number 5 here.
Can you do letter C?
C, let's look at 5C. Right, but do not evaluate. Okay. All right, I'm gonna split this one up into parts. So I am going to find the length of this, and then I'm gonna find the length of this, and then I'm gonna find the length of this. So I'm just gonna call these something. So I'm gonna call this one Y. I'll call this one, I kind of want to start with X because that's the hard part. So I'll call this length X, and I'll call this length Y. And if I can figure out X plus Y plus, what did I say? I'm gonna call it Z. So if I can find X plus Y plus Z, that's gonna give me the perimeter of R. Okay, so I'll start with X. I think I'm going to mute everyone. Actually, yeah, I'm going to mute you. So make sure you unmute yourself if you are, if you need to say something. Just hear some background noise. Oops, I just realized I muted myself too. Okay, so to find X, you want to find the length of the arc. So I'm going to integrate from X equals 0 to X equals 1. So this is the arc length formula. So it's going to be from 0 to 1. So the formula is going to be the square root of 1 plus the derivative squared. So I'll write the formula. So to find the length of the arc, I'll call it arc length up here. Is going to equal, if you're going along the x-axis, it's going to be the integral from a to b of the square root of 1 plus f prime of x squared. So this is what a formula you should have memorized. So I am going to find f, think of y as f of x. So f prime of x, this is my scratch work here. I'm going to do product rule. So it's going to be the first factor times the derivative of the second. So when I take the derivative of e to the x squared, it's e to the x squared times the derivative of x squared, which is 2x. That's chain rule. Plus the second factor times the derivative of the first. So the derivative of x is just 1. So that's going to give me my f prime of x. So to find x, it's going to be the integral from 0 to 1 of the square root of 1.
1 moment.
Okay, this is getting annoying. All right. So 1 plus, then you have your derivative, which is this a calculator question? Oh no, it says don't solve, okay. So x squared e to the, I'll just make this a 2x squared. So I just multiply, you don't have to multiply if you don't want to, but x times 2x is 2x squared, and then e to the x squared. And then what else do we have here? And then plus e to the x squared, and then dx. So that's my x. Now I'm going to find y. So y is going to equal, let's see, if you could do distance formula. Do we know what this point is? I'm missing some. Oh, it's the line y equals negative 2x. So this is y equals negative 2x. And then we're going from 0, 0. So this point is 0, 0. And this point here, you just plug in 1 to that because you know the x coordinate is 1. So that's going to give you negative 2. So this point down here would be 1, negative 2. You can either do distance formula or you can just do Pythagorean theorem. I'm just going to do Pythagorean theorem here. So if you were to create a triangle, this distance right here would be 1. This distance right here would be 2. No, this would be 1, sorry. Picture apparently is not drawn to scale. So this distance would be 2. This distance would be 1 because we're going over 1 and down 2 to get to the point. So if you were to do Pythagorean theorem, it's going to be the square root of 5, I believe. So y equals the square root of 5. So I just did Pythagorean theorem here to find this distance for y. And lastly, to find z. So I'm going from this point down to this point. So we know this point down here has a y coordinate of negative 1. Let's find what this y coordinate is. So right here, to find z, for this equation, intersects with the line x equals 1. So I would just plug 1 in for x and solve for y. So I'm going to plug 1 in for x, so y equals 1 times e to the 1. So if you want to find the y coordinate of this green point up here, you just plug one equation, or the two equations that meet are x equals 1 and y equals x times e to the x squared. So this would simplify to e here. So that means z is just e. So for my final answer, it says to find the perimeter of R. So I'd say perimeter of R equals, it's x, which is this, plus square root of 5 plus e. That was a doozy. So we're just adding x plus y plus z. The distance around the outside of the figure is the perimeter. You would need calculus to find the length of x, the arc.
Why is z just e?
Okay, so why is z? Because if you want to find this green distance here, I know that, oh, I'm sorry. The y coordinate here would be e. So backtrack, not done yet. So I just found the y coordinate, which is e, because I found the intersection of the 2 points. But then this distance right here, because it goes to a y coordinate of -2, this would be 2. So my y coordinate would actually be e plus 2. So I'm going to need that to add that here and then to my answer. So thank you. Did that answer your question? Make sure your mic's on. Did that answer your question? Okay, hopefully we're okay. So yeah, it should be e plus 2. I forgot to add the part below the x-axis. Oh, that would have been sad to lose that point after doing all the hard stuff. Be more careful than I was.
Mr. Morris,
Yes.
did we have to skip arc length formula
Um,
problems?
good question. You do need to know arc length for rectangular coordinates. So that means on an XY axis, you need to know that arc length formula, but there's 2 more arc length formulas you do not have to know. So there's arc length formula for polar. You don't have to know that one. And arc length formula for parametrics. You don't have to know that one either. So you can ignore 2 of the 3 arc length formulas. But this one here, you do want to know this one because that could be on there.
Okay, thank you.
Mm-hmm.
Can you explain one more time how you got the derivative of f of x?
Yeah. So I just did product rule. So it gives me y, which is f of x here. And then doing product rule, I took the first factor x times the derivative of the second. So when I take the derivative of e to the x squared, I do chain rule. So it's e to the x squared times the derivative of x squared, which is times 2x. And then I add the second factor, e to the x squared times the derivative of the first. So the derivative of x is just 1.
Okay, gotcha. And then when you plug that into the arc length formula to find x, didn't you have to square that?
Probably, let me see. Oh man, you are correct. Silly Mr. Morrison. Okay, so thank you. Another mistake here. See, I feel like I got the hard stuff right, but I missed some of the, I was careless on this one. So that should have been squared from the formula because you're squaring the derivative. So that means on my final answer, and I'm glad you caught that. So I would take this here, and then you would square that, and now we should be good. So hopefully there's no more mistakes. So yeah, you need to, from the formula, you have to make sure that you are squaring the derivative, which I neglected to do. So any other questions on number 5?
Mr. Morrison,
Yes.
just to make sure, which are the arc formulas? Like, do we not have to know what are they? What are they actually?
There's one that looks like this. That should be dt. So this one you could ignore. That was one. Let me see if I can find this one. So it's polar. I'm going blank. I'm not in a polar mindset.
Actually, that just that one is good
I think that's like the same thing. Okay.
because
So that's
it's just with r and theta, so I
Yeah,
just know not to
use
do
the
that.
R, so you can ignore that one.
Okay, thank you.
And then dt at the end. Okay, anything else on number 5?
You do
Yeah.
5
5, which one?
B.
Sorry, I wasn't able to hear you. Could you say that one more time?
5B.
5b, thank you. Okay, so let's look at 5b. So we're doing 5b now. So I wouldn't be surprised if you saw a volume question because that ties in a couple different things together. So here I am going to, let's see, rotate it about the horizontal line y equals 2. So we said earlier, what was the y coordinate at this point? We plugged in 1, it was e, right? So this is e. And we are rotating about the horizontal line y equals -2. Okay, got it. So we said right here, this was -2. So this is going to be our axis of rotation. So the rectangle is always perpendicular to the axis of rotation. So I'm going to draw a rectangle here. So someone speak up with their mic turned on. Is this washer or disc?
Disc, I think. Wait.
Yes.
Yeah.
Disc is when it's connected to the axis of revolution. Does the rectangle connect to our axis here at y equals 2?
No.
See, so this one will be washer because there's a little gap right here. See how there's a little hole? When you swing that rectangle around the dotted line, it creates a hole in the middle. So that's how you know, remember the rectangle is always perpendicular to the axis of revolution. So here I'm going to do washer. Or as they say in New York, washer. So I have, it's going to be the integral of big radius squared minus little radius squared, and you can factor out the pi. And I'm going to integrate along the x-axis. So it's from a to b, that's going to become 0 and 1. So this is going to equal pi times the integral from 0 to 1. So it's going to be big radius squared minus little radius squared. Because we're moving along the x-axis, everything is in terms of x. Our radius is in terms of x. Our limits of integration are in terms of x. We're integrating with respect to x. So if you want to go, if the rectangle is going from left to right, then everything's in terms of y. So for the big radius, no matter where you draw it, whether you draw it here, or here, or here, it never changes, going from 0 to 1. The big radius is always going to be 2, from the x-axis to the axis of revolution. So it's going to be, oh, wait, just kidding, we're going to have to do the whole figure. It is changing. So this is changing as you go from left to right. So you need an expression to represent the big radius. So the big radius is going to be 2 plus, it's the y-coordinate of the curve. So it's always going to be, this lower part never changes. It's always 2 plus something. But then above the x-axis, it's always going to use this right here. So it's going to be x e to the x squared. So the big radius, when you swing that whole thing around the axis, the line y equals 2, y equals negative 2, the big radius is always going to be 2 plus x e to the x squared. For the little radius, I'll do that in a different color. It's always going to be the whole. So see, it's changing again. So you need an expression to represent all of those blue lines. So what you're going to do is take this entire distance and then subtract the y-coordinate of the line. So the little radius is going to be 2 minus, well, the y-coordinate of the line is just negative 2x. That already takes care of the negative, though. So you're just going to do 2 minus 2x. So right here, that's what I'm going to write here. So any one of these blue lines could be expressed as 2 minus 2 times whatever the x-coordinate is that it would touch, or the x-coordinate of every single point on the segment. If you did 2 minus 2x, that's going to represent the length of the small radius. So all of this will be your answer. So you have to find the hardest part of volume problems like this one is you have to find an expression that represents every big radius. You have to find an expression that represents every small radius. So if you notice, going from 0 to 1, it's not always the same. Sometimes the radius is bigger, sometimes it's smaller. That's why you have to write it in terms of x, because it's changing as you go from left to right.
Why
So
can't
this,
the smaller radius with negative 2x?
why can't it be negative 2x?
Yeah.
Oh, because negative 2x wouldn't give you the whole. What negative 2x would give you would be the distance from the x-axis. That would give you this distance here. Negative 2x, just the y-coordinate that goes from the x-axis to the graph. You have to come up with an expression that represents the radius inside the hole. So the hole would be 2 minus that distance.
Okay, thank you.
Yeah, these are tricky problems. Hopefully we don't get a volume problem, but you can get anything we've covered all year except for the few concepts I told you they took out can show up on there. Okay, anything else on number 5?
So, Mr. Morrison,
Yes.
if you were to rotate something around like a vertical line, you're
Yeah.
gonna have to change it in terms of y and change the limits of integration.
Yeah, so if you had something like this, well, let's just use this problem. Say you wanted to rotate it around the y-axis. Then your rectangles would go like this. Let me clear this out. So your rectangles would go horizontally. And we said this was E up here. So you would integrate from 0 to E. And then it would be the big radius, which would always be 1. It'll still make a hole. Minus the little radius, which is the x coordinate here. This is your little r. Minus the little radius squared. And everything is in terms of y now. So to find the little radius, that's just the x coordinate of the curve. So the x coordinate of the curve, you would have to get x by itself here, which they wouldn't give you that because there's no way to get x by itself there. That's the transcendental equation. So, but you would get, you just get x by itself there and then plug it in for the little radius. But this wouldn't be, they wouldn't give you this problem and have you do it along the y-axis because there's no way to get x by itself there. But that's the premise behind what you would do.
And one more question, Mr. Morrison. What was the equation for the disk method? Is it just r or?
Yeah, this method, if you're going along the x-axis, it would just be one big radius squared with respect to x. So you don't have to worry about subtracting out the whole.
Okay, thank you.
So yeah, this is disk here. So you have to see it, and how you know if to do disk or washer again. Washer is when the rectangle doesn't connect to the axis of rotation. So the one we just did, the rectangle did not connect to this line down here. So we had to do a washer. I should have done this rectangle higher. Sorry, I don't know why. Originally, I was just focusing on the bottom part. The rectangle should cover that whole space. So last call, anything on number 5? Okay, number 6. Let's see, clear this out. Last problem of 2014. Okay, had you skip A? I guess I could have given you A, but because that would have been good ratio test practice, but I think I skipped A for this one. So questions on number 6.
Can you do C, please?
6C, yep. Okay, so on 6C, so whenever it says geometric series, you can use the formula. So for 6C, so the formula is the starting term over 1 minus r. So to find the starting term here, you need your derivative. So maybe you need to do B first. Let me see. I'll put up for B. I think you need the answer for B, which is the derivative. Okay, so maybe I'll just find the derivative here. So f prime. Whoa. What happened? Why is that so thick? Okay, I'm just gonna do B. What in the world? I have to figure out how to change my settings. Why is it so thick? Does that work? No. Try that. Okay, 6b, sorry about that. So f of x is gonna equal, what do we have here? So I'm gonna subtract 1 from the exponent. Or I'm gonna actually bring the n to the front, and that's gonna cancel out with this n. So it's gonna be 2 to the n. Ah, this is annoying. I don't know, I don't remember doing anything to my settings. I don't see it holding down. Let me put it back up. I don't like having such a thick pen writing, whatever you call that. I don't know if this is gonna fix it. So number 6, 2014. Still. Okay, I got it. So we're good. Sorry about that. It wasn't where I thought it would be to fix that. Okay, let me have to do 6b here. That was just getting really irritating. I wouldn't give myself enough room. Okay, so this is my f of x function at the top here. So if I want to find f prime of x, I'm going to take this n and bring it to the front, and that's going to cancel out with that n. So we have 2 to the n. And then you subtract 1 from the exponent. I want to be able to do a problem like this one, because this could definitely show up on there, having to take the derivative of a series. And we're going from 1 to infinity. So this is going to equal, when you plug in 1, it's going to give you 2. When you plug in 2, it's going to give you 4x minus 1. When you plug in 3, it's going to give you x minus 1 squared minus dot, dot, dot. So that would be the first 3 terms, and you need the general term. So I already have the general term here. So I'll just put that again. So it's 2 to the n, x minus 1 to the n minus 1. Okay, so for part C now. I'm going to use the formula that I wrote earlier. So thank you for your patience on this one. Had some difficulties, but it's going to be the starting term, which is 2. So 2 is the starting term. To find out what r is, what you could do is just take, if you're not sure, you know it's geometric because it tells you that in the problem. So you could just do the second term divided by the first term if you're not sure what r is just from looking at it. So this is going to, when you simplify this, this is negative 2x minus 1. So that's going to be your r. That's what you're multiplying by going from left to right. Okay, so you could, actually this one's probably better to simplify because you're gonna have to do more work with it on the next step. So 2 over, this is gonna be 2x minus 1 when you simplify. So the second part of the problem says use this function to determine that. Okay, so what I am going to do here so this one is centered at 1 because it's x minus c, where c is our center. So we're centered at 1. So I'm going to take the function to which the series converges. Okay. So this would be an answer here. And then I'm going to want to integrate this. Check this. Okay, so this is my f prime of x. So if I want to find f of x, it's going to be the integral of 2 over 2x minus 1 dx. So I'm going to have to do use substitution here. I can't just go straight to my answer. So u equals 2x minus 1. Du becomes 2 dx. And then 1/2 du equals dx. So I'm going to write this as the integral of, actually I don't need this part, sorry. I could have erased it. 2 dx just becomes du. So this is just the integral of du over u. And that's just going to be ln of absolute value of u plus c. So this is going to be ln of the absolute value of 2x minus 1 plus c. And then if we're centered at 1, so it says about x equals 1. And then if you were to find ln of 1, that's going to be 0. So I'm going to use the point f of 1 equals 0, where f of x is, because yeah, ln of 1 is just 0. So this is going to be, so I'm going to say that, I need more room here. So it's going to be 1 equals ln of 2 times 1 minus 1, that's absolute value, plus c, and the first one should be a 0. So it's ln of 1. So c is just 0 when you solve this. So I don't need the c anymore. So that tells me that f of x equals ln of 2, absolute value of 2x minus 1. You don't need the plus c anymore. So that one messed with me a bit. So that's how we determined F, is what it's asking for here. Yeah, that actually could be a problem. I know I keep saying this, but I could definitely see one like this because it incorporates U substitution, integration skills with Taylor series. And so there's kind of a lot of concepts that are tied together in this one. Those are the problems I'd spend extra time on, where it's forcing you to like connect old concepts with newer ones. Okay, I think to wrap it up, I'm just going to talk about the yellow book. So can everyone get your yellow book out? I want to go over a couple things here. I don't know if we're going to have time to do this later, so I thought this would be a good time to do it. I don't want to start 2013 since we don't have much time left. So how about your yellow book?